might affect the decision. Yeah.
Are we doing the ICT?
Oh yeah, you should be. Yeah. Yeah.
Yeah, they sent email yesterday.
Okay, can you see okay? Is that clear enough?
Yeah.
Yeah.
Could you do question 4 and 5?
The optional ones?
Yeah.
Sure, okay. If you open up the questions in the homework, well, you know what? No. I'll do that in the tutorial on Monday.
Okay.
Yeah, so just please remember to circle it or write it down so we can do it on Monday. Okay, this next lesson now. So we're having a look at something called discriminant. Okay, so yesterday we have our formula for x equals minus b plus or minus square root b squared minus 4ac all over 2a. What makes this interesting is that this part of the formula is actually really the most important part because it's inside a square root. You probably know this already, but you cannot calculate the square root of a negative number. Well, you can, but we can't at the moment. You know that the square root of 0 is 0, and the square root of a positive number is plus or minus. It has two answers. So in other words, if this was negative, we have no answers actually. If it was negative. If it was positive, we have two answers, and if it was 0, plus or minus 0 is the same thing, so you have only one answer. So in other words, this part of the formula can tell us how many roots we have, how many answers. And we give this part a name, and no surprise here that the name is called discriminant, and we can use the letter D for discriminant, or I think a lot of people use delta for discriminant. So, if the discriminant is positive, that means 2 roots. If the discriminant is 0, that means 1 root. And if the discriminant is negative, that means no roots.
Would the roots mean like the answer of x?
Yeah, the x, basically. The solutions, yeah. So, we'll look at some examples of how we work with discriminant, but this is the result. This is called the discriminant. And again, I will remind you that I ask that a is not 0, because if it is 0, it's not a quadratic. So the only thing I ask and still ask for this is that a is not 0. I'm sure people have seen this before, but it'll make me feel better if I see you writing it down. Then it's okay, I can go to the principal, she can pay me because it feels like I'm working if you're actually taking notes, you know.
So that negative,
Yeah.
that would mean like no roots, right?
Yeah. So the quadratic hasn't any solutions, unsolvable. Yeah, it doesn't cross the x-axis. Very good. So, just to be clear with how this affects the graph. This is our typical situation. We have 2 roots when the discriminant is positive. This is the situation when the again. There we go. This is the situation when the discriminant is 0, and this is the situation when the discriminant is negative, that it doesn't cross the x-axis. So 2 roots, 1 root, and no roots then. Okay. Let's have a look at some questions then. Can I scroll down?
Yeah.
Yeah. Okay. So we'll do something very easy first. So first example, how many distinct real roots does minus 7x squared minus 3x minus 6 have? Does anybody know this word here? Distinct? What's
Clear.
distinct?
Real.
True? Well, a bit more mathematical perhaps.
Specific. Exact.
Not exact, not quite this. Huh? Different is what I was looking for. So how many different real roots does it have? Because sometimes people say one root is kind of like two roots, it's just that both roots are the same. So it's like, oh, it has a root here and a root here. So to prevent any confusion, we use the word distinct. Does that have 2, 1 or 0? Okay, so let's calculate here. Discriminant is b squared minus 4ac. That's 9 minus 4 minus 7 minus 6. That looks like a negative. It's 9 minus 42, 40, 80, 168, is it?
Yep.
Minus 159.
No real roots.
Yeah, definitely negative, so that means no real roots. Now note that I'm not actually finding the roots, and here I can't anyways. I'm only asking you for how many roots it has. Okay, try this one for me. Same question, but this quadratic. Minus 3x squared plus 6x plus 1.
More than 0. Two.
Real roots.
Yeah, it's a positive answer.
Yeah. Yep.
Then when we write the answers, can we just say like t is bigger than 0, like bigger than the number?
Yeah, not go to the trouble of calculating it.
No. Like I would calculate the number, but not.
This, you
write
mean
it
this
down.
number?
Yeah, and put d on this.
You write
Instead of
d
delta?
is less than 0. That's what you mean? You write
Yeah. Then I'll just like
It's okay because
better than writing the real roots.
oh no, if the question said how many real roots, it would want some. You see,
Well,
you just because okay, if the d is greater than 0, you haven't actually shown to the examiner you know that means
Oh.
2 roots. You know, so it does need something after it.
This has no range of roots.
Let's calculate it.
Full meaning of
e.g. example.
It's Latin, I think.
Which e.g.?
E.g. for example, what it stands for, it's Latin, I think. I don't remember what it stands for. Okay. Discriminant is b squared minus 4ac. That's a positive. 36 plus 12. 48 is a positive, so that means 2 real roots this time. Okay, so that's basic example. Let's make it a little bit trickier now. Okay, can I scroll down? Yeah. Right, same question, this equation. Yeah, we have a k in it now. And here, the only thing I ask is that k is a number which is not 0, and the reason I'm saying that is because it won't be a quadratic if it is 0. In fact, it won't be anything because there's a k in everything. So, it's actually not possible to get the roots here because you don't know what the k is, but it's still possible to know how many roots it has. So let's see what we have. Discriminant is b squared minus 4ac. That's 16k squared minus 16k squared, which is 0. So this means it has one real root. Okay, I'll do another one like this.
Can we use the, do you know the symbol of the 3 points that means therefore?
Yes.
Can we use that?
Yes. Yeah. Do you know all these symbols?
No, I only know that one.
I'll write them down now in a second. Got this? Okay, can I go to the side? Just in case people don't know all their symbols, I'll write them down. So this one is therefore. This one?
Equals to
No, not equal to.
No.
Transfer to?
Say again?
Transfer to?
No.
Leading to?
Leading to, yeah. So implies, or like you said, leading to. This one
Goes back to.
yeah, not quite that.
This implies.
This implies, no.
Drag to.
No.
It's the same.
Thing?
It really kind of is the same. It's just you're pointing the logic in a different direction, you know, like coming from. So it's the same. It's just the direction is different. So here, this is B follows from A, and writing it this way, it means that A follows from B. I mean, it's not really any different.
Yeah.
But what about this one?
They cooperate.
No.
Equal.
Do we know this one? Yeah, what's it called? Does anyone know? That's it, yeah. What's it called? Don't be shy, I heard the right answer. Yeah, if and only if. It means that logically you can go both ways. You can go from A to B and you can go from B to A. Both directions are logical.
What about the first one? Huh?
Oh yeah, here, A to B does not mean you can go B to A, logically. Yeah. This symbol?
Element? No.
No, element's a different one. Do we know this one? Exists, yeah. This one? What is it? Not that?
Degree?
Degree? No.
For sure.
Yeah, for all. Yeah. This one?
No, I don't know.
Anybody? No? Not. Just two more I can think of right now. ST? Striker? No.
Streak.
Huh? No. Street? No. Such that. And lastly, RTP.
Real turning point.
Real turning point?
No.
Ridiculous.
Ridiculous turning point? No.
Ridiculous.
We got, anyone know it?
Root point.
No. Now remember, all these are to do with logic statements, so it needs to be some kind of logic statement.
Rather than
Read the
Now we're thinking better, but not this.
Read the paper.
Required to prove.
Oh.
Oh, and the last one actually, now that I said that, QED,
Forget.
end of proof.
Well, then where did Q come from?
It's again, it's Latin.
Oh.
Quad rad demonstratum. I think meaning what you asked me to prove, I've proved. Yeah, some places use a square to mean end of proof as well.
Oh, what about that? That 2 dots in the upper and the 1 dot in the below.
This one?
Yeah, isn't that Y?
This is one we don't use here, but I think in China they might use this one. Does anyone know this one? Is this a real one, the one that's just upside down of this one?
That is for the
I think I saw it before.
the like Y.
Is this a real thing?
Yes, I remember using it.
Yeah, but that doesn't mean it's a real thing.
I think I saw it before.
Let's have a look. I'll tell you right now if it's real or not.
Oh, I'm pretty sure it's real.
I've got it.
It's okay. No,
Yeah.
it's real.
No, it is. He's right. It is real.
Yes, it's real.
What is it?
Why?
Why?
Well, yeah. This one here is therefore, and this one here is because.
Oh.
Yes. Yo.
Because of. Yes. Okay. So that's a little bit of a refresher on your symbols. You're not expected to know these symbols for the exam, but it is fine if you want to use these symbols in your answer in the exam. Okay. Right. Let's have a look at another example here. I'll let you try it first, actually, see how you do, and then I'll do it. Okay, and the only thing I say is that k should not be 0. Calculate how many roots this has. That 4 is in the formula. See the formula? B squared minus 4AC.
No.
Oh? This one? This one? This one? Yeah. Ah! Yeah, because in fact here, let me just write it down. This is A, this is B, including the 4. Yeah, so this is B. Yeah, it makes sense? Okay, you have an answer?
Yep.
Yeah. Let's have a look. Discriminant is
Minus k
yeah,
9
squared minus 4.
minus k times 3.
Now we can't tell from this if there's 2, 1 or 0. So I'll need to simplify it a bit. This will be k squared minus 18k plus 81 plus 12k.
K squared minus 6k plus...
Great. Computer's getting tired. See, now I'm asking it to do more. Not only does it need to record the lesson, it also needs to convert the image as well.
Oh.
So I'm pushing it to its limits of what it can do. There we go. K squared minus
6k plus 81.
Yeah. Now, at this point, we still don't know if this is positive or negative or 0, because we don't know where k is. So we've no way of knowing.
Factorize.
But we'll not factorize, complete the square. I can change this to x minus 3 squared
plus 72.
Now it's very, very clear. This has to be a positive number.
Yes.
Because the discriminant is a square, which is positive, plus a positive. In fact, it can't be 0. It has to be at least 72. So the discriminant is at least 72. That means it's at least a positive. So, 2 real roots. So what I like about this question is that you can't actually find the roots, but you prove that there are roots.
It's fine if we factorize as well, right?
Here?
Yeah.
No, because factorizing doesn't tell us if it's positive or negative. And in fact, you can't factorize here. There are no factors. So, there exists 2 real roots.
Question.
But we can't know these roots because we don't know the k, but we know that there are 2 roots, even though we don't know what they are. Yeah?
Isn't it as long as we have 2 real roots, that means we can factorize and get the answers of x?
Factorize this,
Yes.
but this is a different quadratic. The discriminant is different to the original. Okay. That one was a bit harder. I'll give you something like this to try now. Oh, well, no, you did try it. I'll go on to the next type then. Yeah? Yeah, go ahead, yeah. You got this, yeah? Okay, I think I'll scroll down. You have this? Last line, okay.
Yeah.
Right. Let's have a look at the next type. Okay. So, something like this. Minus 9k minus 9 minus 9k minus 9 x squared plus 4k plus 2x. No, sorry, I'm looking at the wrong thing. I know, life. Plus 6k plus 6x minus k. Right. Find k if the above has 2 real distinct roots. Okay, I'll do this one now. What is the only thing we need to impose on the k? K should not be... K could be 0. K could be less than 0.
No, the discriminant can't be less than...
K should not be minus 1. Why? Because this cannot be 0. If it is 0, it's not a quadratic. And if it's not a quadratic, then I cannot use the discriminant. So I know I don't know what k is yet. I just know it's not minus 1. Now we can look at the discriminant. If it was minus 1, this would be 0, which is the problem.
Can we get a minute to try solving?
You want to try it first? Okay, go for it then. So you can try and solve this first.
Is the bracket squared or is the x squared? The x is
In the question, the square is only on the x. Got an answer?
almost.
Yeah.
Second.
Almost.
Okay. If it has two real roots, the discriminant should be positive. So discriminant should be positive. So that means b squared minus 4ac should be positive. 36k squared plus, what's this, 72 is it?
Yeah.
72k plus 36 minus by minus is a plus. 4 by k by 9k is 36k squared, isn't that right?
Minus.
Yeah. Is it minus? Minus, minus, minus. Sorry, there's three minuses. And then minus, 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 minus again. 36k should be bigger than 0. Now what's nice here, and I made the question do this on purpose, these two cancel. 72k minus 36k is 36k, and plus 36 greater than 0, 36k greater than minus 36, so k greater than minus 1. And k not equal to minus 1, but that's fine because we're also saying here k should be bigger than minus 1. So this is the answer here.
So it has two roots?
No, we know it has two roots because that's given to us. And we're asking what is the requirement on the k. K must be bigger than minus 1, so it has its two roots. Okay, write that down if you didn't get it, and I'll give you some questions to try now.
Just a quick question.
Yeah.
K is not equal to minus 1.
Yeah.
Yeah. So it cannot be -2, it can't be anything lower than that, it can only be higher than that.
Yeah, so here, like, on the number line, if you were to picture it, k is any number bigger than and not including -1.
And then you draw the arrow, yeah.
So, like, it could be 2, 1, 0, can't be -1, definitely can't be -2 or -3. Yes?
I made a gigantic mistake.
Coming here this morning, was it?
Probably.
Okay. Right. 1
sign.
x, 1 y and 1 z. 2 x, 2 y, 2 z. And then 3 w, 3 y, 3 z. Okay, so this is what your homework would be, and you can start it now for a few minutes. So just write these down, please, and you can start doing them now.
So, like, we have to do X, Y, Z, Z for every question.
No, look carefully.
W.
W.
The question right up to Z.
Mhm. I like making lots of questions for my students. You must appreciate all these questions were made by me, just for you guys.
Yes, yes. The plan is I solve all of them before the exam.
It's a good plan. I've only ever seen that happen once.
That's what I did for my high school. Before the final exam, I took the full book and I solved each and every question of it. What a lifeless person.
Sounds great to me. Right, can I close this screen here? Did you write these down?
It worked.
Yeah, you know when I said it'd be activated on Friday? Yeah, you probably weren't realising that I was lying to you at the time. What I really meant
Friday
was
night.
it'll be activated Friday
Nice.
night.
Oh, okay.
Yeah. So you know, during that pre-physics class, that's when I'll get to sit down and make the accounts, okay? So after this time, hopefully it'll be activated. Okay, can I close this?
Yeah, he's gonna like turn on the code.